want to study metal ligand chemistry. What we want to study? Metal and ligand chemistry. So everybody very well known about the coordination chemistry. Then and then only the student should understand the coordination chemistry. Okay, so in coordination chemistry, you know that there is a coordination sphere is there, then primary valency, secondary valency. In primary valency, there is a it determines the oxidation state, while the secondary valency it is a subsidiary valency, and the secondary valency is called as a coordination sphere, while primary valency is the outermost valency, that is outer sphere. So that primary valency and secondary valency is divided into inner sphere and outer sphere. So secondary valency is the inner sphere, while primary valency is the outer sphere. So that all things and all concepts you should know that. If you know that, then and then you will understand what is meant by the coordination chemistry. Because this coordination chemistry in your TYBSc, it explains that there is a chemistry between metal and ligand, how the complexes are formed, and how the chemistry in between that. So you know that ligand having electron rich center, and that's why it's a lone pair of electron containing its orbital, while metal they always loses the electron, and that's why it has the positive charge. And when it loses electron, at that time it's a outermost state of metal having what? There is a empty atomic orbital. So these are the essential conditions for the formation of the compound, like overlapping of atomic orbital of metal with the ligand, then and then sharing of electron pair takes place between them, and this is the main cause for the formation of coordination bond. So coordination covalent bond is formed between metal and ligand. Yes, yes, all you know that idea? Yes or no? Hello, are you getting that point? Yes or no? Anybody say? Manisha?
Yes, sir.
Yes, sir.
Okay. Okay, very good. So on the basis of that, we would like to see this PowerPoint presentation. So in this, what we want to see, what is mean by the inorganic reaction mechanism. So when we understand this inorganic reaction mechanism, then it is easy to understand the next concept related to this inorganic reaction mechanism. So what happened in this case? The inorganic reaction mechanism is similar to the parallel. It parallel to organic chemistry. Means what? Many terms and concepts are the same as in organic mechanism. Complex geometric are more common in inorganic complexes. So geometric means what? You know that the stereochemistry. So arrangement of the that ligand and metal, and that are more common in what? Inorganic complexes. So more arrangement are possible, and B is more isomeric are possible. Okay. So depending upon the arrangement, isomers are there. So the position of atom or arrangement of the atom going to changes, the isomer also changes. So according to arrangement, isomers are there. Not all the metals ions react alike. All carbon atoms do. So you know that the carbon, lot of chemistry of carbon is there. And what is the important property of carbon? Anyone? Yes, because along with inorganic chemistry, you also studied the organic chemistry, and you know that study of organic compound is the hydrocarbon. So why this carbon is the study of organic compound? Anybody? You know the reason behind it? Yes. You know, or yes or no? You know, carbon is tetravalent, okay, and it having most important property, that is the chain forming ability, that is catenation property. And due to that catenation property and tetravalency, the carbon play an important role in the formation of the base of organic chemistry. And the base of organic chemistry is what? Hydrocarbon, carbon and hydrogen. And this is due to because of the special property of carbon. Okay. So if you see history and goals, that Werners and Jorgensen discovered many of the basic reactions. So Werners theory, you know that. Anybody remember which example we studied in Werners theory? Yes. Gayatri Kanse. Gayatri Kanse, please unmute. Which examples we studied in Werners theory? Gayatri Kanse. If anybody not give answer, I consider their absentee. Okay. If you don't have answer, just you don't you say, sir, I have no answer or no. But if you keep quiet, then I will consider to you as a absent for this lecture. So Gayatri can say, Gayatri can say, yes. You know about this, which examples we studied in Werners theory? Yes or no? Gayatri can say, Gayatri can say, give the answer. You studied which example in Werners theory? Yes or no? Sachin Jadhav?
Yes,
So
sir.
Gayatri can say left the meeting. Which example we studied in the Werners theory? If you don't know, then you say, sir, I don't know. Sachin? Sachin
No,
Jadhav.
sir, I don't know.
Okay. So, Pooja Babar?
No,
Pooja
sir.
Babar? Prachi
No,
Jadhav?
sir.
Prachi Jadhav? Prachi Jadhav? Prachi Jadhav? So you remember that your internal is right now going on, and your day-to-day performance in our hand. So all those things. If a student not behave in that way, so definitely you reduce your own marks. So Prachi Jadhav, Prachi Jadhav, you are present or not? Prachi Jadhav, Prachi Jadhav, I am audible to you. So I not giving the answers. ओके ओंकार दिघे.
येस सर.
हा काय आपण एक्झाम्पल बघितलं होतं माहित आहे का?
नाही सर.
ओके नो प्रॉब्लेम. प्रतिमा भोसले. प्रतिमा भोसले. So for everyone, because if you not understand that concept, then how you can study the reaction mechanism in Werner's theory? Which example we studied that you know that you don't know that, then how you can understand the next higher classes concept? So further, I would like to share one video and hope so you will understand it. So you are able to see? Yes or no? Hello.
Yes, sir.
Yes, sir.
Okay. So what is that example? Cobalt, ammonium chloride. Okay. Do you know this example? This one CO NH3Cl3. So central metal ion is cobalt. Nearby it there is a six ammonia molecule. You know what happened? If you see, this is the coordination sphere. It is called as the non-ionizable sphere, and this outermost is called as the primary valency, and this primary valency is what oxidation state of the metal. So this is the metal where this coordinate covalent bond formed by six ammonia molecules and three primary state. Okay. You studied this? Are you remember? Are you remember? हाँ सर बोलो ना.
Yes, sir.
Hello. Okay. Just wait. Hello sir. अरे thank you. No problem. एकदम एकदम outstanding activity. Good day. Okay, so this is the example we studied in Werner's theory. Along with that, if you see the number of ligand is reduced. So here the one of the chlorine from here that enter into the second, that is the inner sphere, and the valency of primary and secondary is satisfied by this Cl minus ions. Again, if you see, we reduce one more ammonia, then another chlorine atom enter into coordination sphere and it satisfy primary as well as secondary valency. And in last example, there is a NH3Cl3 is there. Then and then the three chlorine atom from the outer sphere are come into the inner sphere, that is non-ionizable sphere, and they can satisfy primary as well as secondary valency of this cobalt. Okay. All of you understand? So which example studied in case of Werner's theory? अरे आता तरी सांगा कोणतं एक्झाम्पल आपण बघितलं?
Cobalt ammonium chloride.
कोबाल्ट अमोनियम क्लोराइड. व्हेरी गुड. तर हा जर कन्सेप्ट आपल्याला जर माहित असेल ना, तरच आपल्याला इनऑर्गॅनिक रिएक्शन मेकॅनिझम काय आहे ते समजणार आहे. ठीक आहे. तर then we move towards our reaction mechanism. So here history and goals of what that Werner and Georgeson discovered many of the basic reaction. Experimentation over many years has yielded proposed the mechanism, and that mechanism can't be proven, only disproven is there. We can't directly observe individual molecules react. Evidence either support a mechanism or rule to it. And what is the goal? Synthesize and predict the products by choosing the appropriate reaction condition. Okay. And the type of reaction is what? Substitution reaction, oxidation reaction, reduction, and ligand reaction. Okay. So this inorganic reaction mechanism, we would like to see the two concepts. Okay. And what are that two concepts? That is reaction of metal complex. So you should know that what we want to see in coordination chemistry. In coordination chemistry and inorganic reaction mechanism, first concept we would like to see, that concept is what? It is a reaction of metal complexes. Okay. So Anybody know that what is the metal complex? Yes. मेटल कॉम्प्लेक्स म्हणजे काय, कोण सांगू शकेल? येस और नो? In case of inorganic reaction mechanism, we would like to see what the concept of metal complex. So reaction of metal complex. So everybody know that what is meant by metal complex. So metal complex is what? It is a metal, any metal which attached to the ligand by which bond? Coordinate covalent bond. Then it forms the complex, then it is called as a reaction complex. Yes? So metal complex undergo variety of reaction like or molecules, and the activities of the complexes are some react slow. Okay. So during time of preparation, you know that you carried out number of preparation. In last semester, you all of you did some practicals, and in that case, you also do the some preparation. In some of the cases, the product immediately comes out, but some of the cases which don't have it requires longer time for the obtaining the product. So the kinetics of reaction is too important. Okay. So reaction of metal complexes is either fast, either slow, or it is different manner. Okay. So on the basis of they are react with other complexes, they are classified into liable and inert complexes. Which one? Liable and inert complexes. Okay, so what is meant by that complexes that we would like to see? Liable and inert complexes. So a complex which reacts rapidly is called as liable complexes. A complex which reacts slowly is called as inert complexes. So it is very simple task for the understanding of these complexes, because you know that the inert gas. Okay, Omkar, can you say the name of noble gases? Omkar? Omkar, yes, I am audible. Somnath? Somnath, please unmute yourself. Okay, so I think 57 students are here. So can any one student says that what is the names of noble gases? Yes. Anybody?
Argon, xenon,
Okay.
argon,
Helium.
xenon, helium.
Okay. Shivani?
Yes, sir.
Say the name. Argon. Okay, so we start from what? Helium. Helium, then neon, then argon, then xenon or krypton. Krypton, xenon, and radon. And last element of this noble gas is what? Pratima? Astatine is not, it is in the family of halogen. Yes. So its number is 108. No, 118. What is that?
Radon. OG.
No.
Oganesson, काय?
Which one? Somnath?
Organoson.
Organization.
Okay. So its name is unoctium. Okay. So Somnath says the name of it. So this is the noble gas family, and you know that noble gas elements are not reactive. It is inert in nature. Okay. So these metal complexes are classified on the basis of their reactivity. Those are react fast and those are react slow. Those react in slowly manner, then that complexes are called as a inert complexes, while those complexes react in fast manner, then it is called as a, yes, liable complexes. So the metal complexes are classified into two classes, that is liable complex and inert complex. Yes, all of you understand it?
Yes, sir.
So these two terms, liable and inert, relatively refer to the rate of reaction and are not related to instability and stability. Okay. So whatever these terms, that is inert complex and liable complex, are related to the reaction mechanism, and you know that the definitely the rate of reaction and mechanism is fast in liable complex than the inert complex, and depending upon that they shows the instability as well as stability of the complexes. So the term stability or instability refers to the thermodynamic character of the complex to exist under equilibrium condition. Okay, so just you see that number of factors associated with the stability of the compound. So you know that you are the students of graduate, okay, and why you are studied? Because after your graduation you are having opportunity to do good job. So why you will get good job? Why you want to uh, know that you want the good job? Why? Because of the stability. Those are uh, doing well study in the graduation. Definitely in entrance examination he will get the good marks and he go for the MSc. So you know that when you go for the company, the BSc student having less salary than the MSc student, and after MSc you want to go into the industry, you getting good payment, but when you go there, at that time you realize that if your doctorate is completed, then and then you also having very good salary. And that's why the number of students go for the PhD courses. And if you completed your PhD and you join the industry, you're getting outstanding salaries. So why these all activities are there? Because of the stability. Okay, and that stability is associated with the energy, and that energy is nothing but the thermodynamic. Okay, and that thermodynamic is comes under the equilibrium condition. So all of you know that during the formation of atom, some molecules are added there, and the energy is what it is. Also, the energy is evolved. Okay, in sometimes it is absorbed, in some time it is evolved. So endothermic, exothermic, like a mechanism is there, and that's why this thermodynamic property related to this liable and inert complexes is important. Okay, and that equilibrium is there. So suppose we take an example of mercury tetracyanomercury 2 minus is thermodynamically very stable. The thermodynamic stability of complex is related to its formation constant. Higher is the formation constant, greater is the stability. And thus for tetracyanomercury, the formation constant is very high, and it is about 1 into 10 raised to 42. Okay, and that's why this stability is associated with the energy. Okay, that is the formation constant. All of you understand it? Yes or no?
Yes, sir.
Then the kinetic nature of this complex, that is liability or inertness, is not decided by its thermodynamic stability alone. It is influenced by other factors also, such as the thermodynamically stable, such as the nature of the reactant, temperature, solvent, etc. Thermodynamically stable, it can react fast with some reagent and form the corresponding compound. Okay, so you should understand here, if the inert complex is there, then the rate of reaction is slow, and we not expect much more things from the inert complex. But the complex is liable, so it definitely react very fastly with the surrounding matter or integers, and forms the different complexes with having the different structure and different that is thermodynamically aspects. Okay, so all of you understand this one? Yes or no?
Yes, sir.
Yes, yes, sir.
So Poonam Chaudhary said to me, how many metal complexes are present? Shivani, how many metal complexes are there? Why you having allergy to not do the answer? Please unmute your mic and give the answer. Yes or no or no. Because you know that teaching is not a one-way communication. It is a two-way communication. And if student understood very well, then that concept is most important. Okay. So Shivani, Komal Chavan, Komal Chavan, Komal Chavan. Yes, I am audible to you. Hello, Komal Chavan. Komal Chavan. Yes, I am audible or not? तुमच्या पॅरेंट्स बरोबर मीटिंग घ्यायला लागते मला. कोमल चव्हाण, आवाज येतोय का नाही? So you are absent today, okay? प्रतिमा भोसले, प्रतिमा भोसले. Yes, I am audible or not? Anybody say?
Yes, sir.
Shivani?
Audible.
So why the student not give the answer? Pratima Bhosle? Pratima Bhosle. So I am not giving you marks. Yes? It's very difficult now. Somnath,
Yes, sir.
what is the answer? How many
Six
metal
complexes,
complexes?
sir.
How many metal complexes are present?
6.
Which one? Yes, which one?
No, sir. I can't.
Okay, you can't. So just now we see how many reaction metal complexes are present. So I would like to ask the question to Kishori Gore is there? Kishori Gore?
Yes, sir.
Yes, Kishori Gore. Kishori Gore.
Yes, sir.
How many reaction metal complexes are present? Yes. You just if you don't know, then say you don't know. Kishori Gore.
No, sir.
अरे आता आपण बघितलं ना, आपण आता रिएक्शन मेटल कॉम्प्लेक्स. शिवानी कोणते कोणते बघितले? शिवानी
Yes, sir.
कोणते कोणते मेटल कॉम्प्लेक्स बघितले आता आपण? अरे ज्यांची नावं मी तुम्हाला सांगितली ना.
Tetrahedral.
आता आपण कुठेतरी टेट्राहेड्रल कॉम्प्लेक्स बघितला का? अनिता गुरव. अरे आपण दोन टाईपचे कॉम्प्लेक्स बघितले, एक लायबल कॉम्प्लेक्स
But
आणि
complex.
दुसरा इनर्ट कॉम्प्लेक्स. आणि हे जर आपल्याला सांगता येत नाही तर इट्स व्हेरी डिफिकल्ट. नाउ what is this liable complex and what is this inert complex, and on the basis of that we would like to see their reaction as well as mechanism. Okay. So for that purpose you have to read the different examples related to the reference book, that is coordination chemistry. Okay. So Prachi Jadhav, Komal Sawan, you are absent today because you will not give the answer. Okay. So with this today we will stop here. Okay. If any doubt, please ask me. Okay. So we stop today here. See you tomorrow. Okay, now sir, I'm the today, so I would like to continue. Okay, so say to everyone, please join the class. Only 36 students are here. So all of the students convey the message. Lecture is start and please join. Okay, Shivani, you convey the message, please.
Yes, sir.
Okay, just now we discussed about the two type of metal complexes. One is the liable and another one is the inert. So metal complex are react fastly while this inert complex that react very slowly. So just I would like to find out the whiteboard. Just only how many students join? So 43 students. Now in previous lecture 60 students are there. So why this is because okay. So everyone see this board? Yes or no? Hello? 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 Yes, I am audible. Yes
Yes,
or
sir.
no? So
Yes.
just say me, you see the whiteboard or not? Okay. So you see this whiteboard? Yes or no?
No, sir.
So just wait. So just wait here. So I would like to share the screen, then you will see. Okay. Okay. So you are able to see the screen.
Yes,
Yes,
sir.
sir.
So this is okay. So here just we type the liable and inert complexes. So we would like to see this liable and inert complexes. So this liable complex is what? It is a very reactive and faster, rapidly reacts. Then it is called as a liable complexes. While this inert complexes is what? It is a slowly react. The two terms, that is liable and inert, relatively refer to rate of reaction and are not related to the instability or stability. Okay. So means what? That two complexes is related to what? So these two complexes related to what? Rate of reaction. Rate of reaction, and it is not related to what? This stability. I think it is not that much easy or powerful tool for understanding the concept, but we try to see. So what we say? It is not related to what? Stability or instability of the complexes. Yes, you are willing. Yes, are you seeing this one? Yes or no?
Yes, sir.
Hello.
Yes, sir.
So whatever this liable and inert complex that are related to only rate of reaction, and it is not related to what? the stability and instability of the complexes. The term stability and instability refers to the thermodynamic character of complex to exist under equilibrium condition. So whatever this stability as well as instability, it is related to what? It is related to the thermodynamic character, and this is it exists under equilibrium condition. So we not seen the stability and instability because it is related to the thermodynamic character under equilibrium condition. And for example, here they give the example like this is what mercury. So mercury cyanide is there. Or okay, and here 2 minus is there, and this 2 minus is at the 2 minus is the charge on this complex. So this is what tetracyanomercury is thermodynamically very stable. So it is thermodynamically very stable, and that's why the thermodynamic stability of complexes is related to its formation constant. Higher its formation constant, greater the stability. Thus, for this molecule, formation constant is very high. Okay, so if you see here, this tetracyanomercury, it is thermodynamically is very stable one, and due to that, the thermodynamic stability of complex is related to the formation constant. So if you see this thermodynamic thermodynamic stability is related to what? Is related to formation constant. Okay, so formation constant is nothing but the formation of that compound, and this compound is thermodynamically stable. That's why its formation constant is directly related to the thermodynamic stability, and higher its formation constant, greater the stability. So here higher is the formation constant, higher is what? Stability. So this mercury tetracyano compound is thermodynamically very stable, and that's why its formation constant is also higher. So for this compound, formation constant is very high, and it is about 1 into 10 raised to 42. Okay, so 1 into 10 raised to 42. 10 raised to 42. Its formation constant. So the kinetic nature of complex, that is liability or inertness, is not decided by its thermodynamic stability alone. It is influenced by other factors such as thermodynamically stable. It can react fast with some reagents. For example, its exchange reaction with isotopically labeled cyanide ion is extremely rapid. On the other hand, the thermodynamically unstable, it was low formation constant. Okay, so here what you remember that if formation constant is more, more thermodynamic stability is there. If formation constant is lower, then lower is thermodynamic stability. Yes. All of you getting this point? Yes or no?
Yes, sir.
So thermodynamic stability is cannot interfere the rate of reaction, but from the concept of this formation constant and thermodynamic constant, we can assume that what are the reaction types are there. It may slow, it may fast, and only not that factor, that is formation constant. Our thermodynamic stability is not the factor which assigns the rate of reaction. Along with there, many other factors such as the reagents, some reagents which play and role for the determination of this rate of reaction, and that is nothing but isotopic labeled cyanide. So you know that here is the cyanide group. Okay, so this cyanide group, and here the carbon atom is labeled. So it is called as what? Isotopic labeling method. Suppose we draw here on that carbon dot, and this are set into the reaction. Then according to this isotopic labeling method, we can know how the dissociation of that complex takes place, where the living entity is cyanide or it is not. Okay, all of you understand this one? Hello.
Yes, sir.
तर काय इथं मी तुम्हाला पुन्हा एकदा सांगतो, कारण की हा कोऑर्डिनेशन केमिस्ट्री टॉपिक जो तुम्हाला आताच्या ह्या सेमिस्टरला आहे, तर त्यासाठी तुमचा कोऑर्डिनेशन केमिस्ट्री बॅकग्राऊंड स्ट्रॉंग असणं फार महत्वाचं आहे. तर तुम्हाला काय होतील, कन्सेप्ट अंडरस्टँडिंग होतील, अदरवाईज होणार नाहीत. म्हणजे तुम्हाला तिथं माहित पाहिजे की तुम्ही काय करणार आहात. कोऑर्डिनेशन केमिस्ट्री म्हणजे काय, मेटल लिगँडचं फॉर्मेशन कसं आहे. ओके, या सर्व गोष्टी जर माहित असतील तर ह्या गोष्टी अंडरस्टँडिंग होण्यासाठी जास्त वेळ लागणार नाही. तर आपण इथं काय बघतोय की मेटल कॉम्प्लेक्सेस मध्ये दोन टाईपचे कॉम्प्लेक्सेस आहेत, लायबल कॉम्प्लेक्स अँड इनर्ट कॉम्प्लेक्स. आणि हे दोन जे काही लायबल आणि इनर्ट कॉम्प्लेक्स आहेत ते कशावरून त्यांना नाव दिलेले आहेत, लायबल आणि इनर्ट, तर त्यांच्या रिॲक्टिव्हिटी. म्हणजे जे कॉम्प्लेक्स फास्ट रिॲक्शन देतात त्याला लायबल कॉम्प्लेक्स म्हणायचं, आणि जे कॉम्प्लेक्स स्लो, एकदम स्लो कॉम्प्लेक्स फॉर्म करतात त्याला काय म्हणायचं, इनर्ट कॉम्प्लेक्सेस. आता हे जे काही इनर्ट कॉम्प्लेक्स आणि लायबल कॉम्प्लेक्स हे जे काही दोन फॉर्म आहेत कशाचे, मेटल कॉम्प्लेक्सचे, तर याच्या थ्रू आपल्याला काय शिकायचं आहे, वी वॉन्ट कोरिलेट इट टू द determining the rate of reaction. Means what, it is called as a kinetic control. Okay, or it is called as kinetics, because we have to understand the rate of reactions. It may be fast, it may be the slow, according to the nature of metal complex, and that's why by these two types of metal complexes we should understand the kinetics of the reaction. Okay, सगळ्यांना समजलं? Yes or no?
Yes, sir.
हॅलो, अरे समजलं का सगळ्यांना?
हो सर.
हॅलो, ओके. त्याच्यानंतर काय आहे की जे काही रेट ऑफ रिॲक्शनशी कोरिलेट असणार आहे त्याचा आणि थर्मोडायनेमिक स्टॅबिलिटी किंवा इनस्टॅबिलिटी याचा काही एक संबंध नाही. ओके, सो थर्मोडायनेमिक स्टॅबिलिटी इज डिपेंड्स अपॉन द फॉर्मेशन कॉन्स्टंट. म्हणजे तो कंपाऊंड कसा फॉर्म झालेला आहे. फॉर एक्झाम्पल आता इथं आपण बघितलं एक्झाम्पल मर्क्युरी सायनाइडचं, तर 4 मोलिक्यूल ऑफ काय, मर्क्युरी सायनाइड, अँड ओनली 1 मोलिक्यूल ऑफ व्हॉट, मर्क्युरी, they can arrange to form metal complex, and that metal complex is nothing but the tetracyanomercury. Okay, तर हे जे काही त्यांचं फॉर्मेशन झालं मीन्स हाऊ मर्क्युरी रिॲक्ट विथ द सायनाइड, the 4 molecule of cyanide is there, how they can react. Depending upon that, the stability can measure. So the formation constant means formation of Hg and cyanide. The reaction between mercury and cyanide is done, and after that, whatever the compound is formed, that is metal complex, that mercury cyanide, and that mercury cyanide determines the stability, that is called as thermodynamic stability. So it depends upon the formation constant, and the formation constant is higher, then higher stability. Okay, and if formation constant is lower, then lower is the stability, means it go towards what? Instability. So here two aspects we see. First one is stability and non-stability, and second one is the fast reaction and slow reaction. But this kinetic and thermodynamic are two parts, and they are apart from each other. They cannot depend upon one another. While the formation constant is important for the stability, but along with that, many other factors like reagents, conditions, that also play an important role in the formation of this molecule. Okay, all of you understand? अरे समजलं का?
Yes, sir.
कोणाला काही शंका आहेत का याच्यामध्ये? Yes, you have any doubt regarding this? Yes or no? सौरभ, सोमनाथ, काय डाऊट आहे का? ओके. तर दोन मेटल कॉम्प्लेक्सचे टाईप आहेत आणि ते डिपेंड्स कशा होते कशा होते. तर मला इथं आणखी एक एक्झाम्पल द्यायला तुम्हाला आवडेल. सो यू सी दॅट एक्झाम्पल. The next example we would like to see. So here कोण वाचेल का? याचं नाव काय असेल सांगा कोणीतरी. And 3+ is there. Okay, याचं नाव काय असेल? Yes, anybody? भावना जाधव, याचं नाव काय सांगा. याचं नाव काय? CO. CO means what? CO means what? भावना जाधव. Yes. अरे भावना जाधव तुम्ही प्रेझेंट आहात का नाही? नाहीतर तुमचे ऍबसेंटी लागेल बघा. नो. अरे प्रेझेंट आहे का तुम्ही? भावना जाधव, so प्राची जाधव, कोमल चव्हाण, then right now भावना जाधव. ऋतुजा जाधव, ऋतुजा जाधव. अरे या कंपाऊंडचं नाव काय आहे? कोण सांगेल का? $36 स्टुडंट्स आहेत. कोणाला एकाला नाव सांगता येईल का?
हेक्सामाइन कोबाल्ट.
येस और नो? हेक्सामाइन कोबाल्ट. व्हेरी गुड. तर याच्यामध्ये एक कोबाल्ट मॉलिक्यूल की ज्याची व्हॅलेन्स किती आहे? 3+. हा कशाबरोबर रिॲक्ट होतो? 6 अमोनिया मॉलिक्यूल बरोबर. आणि आपण प्रिव्हियस जे एक्झाम्पल बघितलं त्याच्यामध्ये काय बघितलं आपण की मर्क्युरी सायनाइड देर इज फॉर्मेशन. ओके, तर मर्क्युरी सॉइनेट मध्ये जो काही फॉर्मेशन कॉन्स्टंट त्याला बीटा म्हणायचं, तो किती होता? इज इक्वल टू 1 इंटू 10⁻42. आता मी तर थोडस गॅप देऊन लिहितो आणि त्याला रेड पेनने असं थोडस राऊंड करतो, कारण की हा काय 10⁻42 आहे. ओके, आणि दुसरा जो रिएक्शन आहे आता कोबाल्ट क्लोराईड, याचा जो फॉर्मेशन कॉन्स्टंट आहे इज इक्वल टू 1 इंटू 10⁻⁻25. तर याला पण मी काय करतो, -25 ला राऊंड करतो, कारण हा काय 10⁻² आहे. So the cobalt ammonium chloride can be prepared from aqueous medium and stored in the laboratory. This is possible because its reaction with H2 in acid is very slow. Okay, तर हे जे काय कोबाल्ट अमोनियम क्लोराइड आहे, इट प्रिपेअर्ड फ्रॉम aqueous medium and stored in the laboratory. This is possible because reaction with H2O in acidic medium is very slow. तर आपण हे रूम टेम्परेचरला सुद्धा काय करू शकतो, लिक्विड फॉर्म मध्ये स्टोअर करून ठेवू शकतो, कारण जी काय रिएक्शन आहे इट इज व्हेरी स्लो. समजलं सगळ्यांना? डू यू अंडरस्टँड? हॅलो, अरे ए ग्रुपचे स्टुडंट असे का करता तुम्ही? वाय यू आर नॉट गिव्हिंग आन्सर? येस, अरे समजलं का तुम्हाला? येस और नो?
येस सर.
चालेल, तर थोडस काय करा तुम्ही, जे काय बुक्स वगैरे मिळतील मी तुम्हाला नोट्स प्रोव्हाइड करेनच, पण जे काही तुम्हाला मिळतील त्या अनुषंगाने तुम्ही थोडस वाचन करा. हा तसा टॉपिक डिफिकल्ट आहे फॉर अंडरस्टँडिंग, तर याच्यासाठी तुम्हाला खूप कष्ट घेतले पाहिजेत, आणि हा मोस्ट इम्पॉर्टंट टॉपिक आहे, कारण की मॅक्झिमम क्वेश्चन याच्यावरती असणार आहेत. ठीक आहे, समजलं सगळ्यांना? ओके, तर ठीक आहे, आपण आज इथे थांबू. हा बोला सोमनाथ.
सर समजलं असं.
ओके, तर आज आपण इथं थांबू आणि नेक्स्ट लेक्चरला भेटू. ठीक आहे, सो हॅव अ नाईस डे. थँक्यू व्हेरी मच. सो एव्हरीवन लीव्ह द मीटिंग. Everyone leave the meeting. Please, everyone leave the meeting. Otherwise, I would like to end the call. So, everyone leave the meeting, please. Pooja Anbule, Mayuri Gurav, Monica Kardure, Saili Bise, Mayuri Kanse.
Present, sir.
हाँ, प्रेजेंट देऊ नका. यू हैव टू लीव द मीटिंग. ओके. केदार भोसले, बागल, निशा गायकवाड, तर लीव करा मीटिंग. नेहा अनुभवने, अंकिता चव्हाण, अनिकेत धनवडे, अरे सगळ्यांनी मीटिंग लेफ्ट करा.